here we are going to compute the limit as x approaching infinity of this expression, and if we plug in infinity into all the x's, in fact, we will end up with infinity minus infinity, but we cannot say this is equal to 0 right away. It could be equal to 0, but this is an indeterminate form. So in fact, we will have to do more work. So what do? Here we have a square root. So it's a good idea to use the conjugate. Therefore, let's multiply out the bottom and the top by square root of 9x squared plus x, and then change the minus to a plus, and then we still have that 3x. And let's do the same thing on the bottom. Square root of 9x squared plus x, and then plus 3x. So let's see what we get. Let's write down the limit as x approaching infinity. When we multiply the conjugates, we just square the first, so we will get 9x squared plus x. And then we minus the second term square. 3 squared is 9 and x squared, right? So we have 9x squared. And then on the bottom, same thing, just leave it square root of 9x squared plus x plus 3x. Okay? And as we can see, this and that cancel each other out nicely. So in fact, on the top, we just have the plus the x, so that's good. Okay, and when x is approaching infinity, we are going to pick out the biggest power of x on the top and also on the bottom, namely the dominating part, right? So that's the only thing that we have. And for the bottom, we're going to pick this up because we have x squared. Yeah, but it's inside of the square root. So in fact, square root square cancel. This is the same as x to the first power. So we will also have to consider this because this is also to the first power. This right here, square root of 9 is 3, and then square root of x squared is x. And you see, x is approaching past infinity. So this and that cancel out to just be x. You don't have to put the absolute value, all right? So in the end, we are looking at the limit as x approaching infinity. On the top, we have x. On the bottom, we have this and that together, which is 6x. Cancel out the x, and you know the answer will just be 1 over 6. So this example is similar to the previous one, but here we have the limit as x approaching negative infinity. This one is a little bit trickier. I will tell you guys what to pay attention to later on. But let's see, if we put negative infinity into all the x's, well, when we put negative infinity to here, we square that, it becomes positive infinity. And if you worked out everything here, I will tell you, we will end up with positive infinity here. Even though the inside here seems to be like we get infinity minus infinity, but this is the dominating part, right? And then if we put negative infinity to here, 2 times negative infinity is negative infinity. So here we have my infinity minus infinity case. We cannot say the answer is 0. We don't know. It could be, but we have to do more work. Let's use the conjugate again, just like the previous one. So let's go ahead, multiply the top and bottom by 4x squared plus 3x, and then change the plus to a minus, and then we have the 2x. And then let's do the same thing right here. 4x squared plus 3x, and then minus 2x. All right, multiply out the top. Let's write down the limit as x minus as x goes to negative infinity. And then we have square the first part, which is just 4x squared plus 3x. And we will have to minus the square of the second. 2 squared is 4, x squared is just x squared. And the bottom stays the same. So let's write down square root of 4x squared plus 3x, and then minus 2x. Cool. Cancel, cancel. On the top, this is the only thing that's left, right? And because x is approaching negative infinity, we don't need to worry about this. We do just have to worry about this and also that. Now, here is the tricky part. Square root of 4 is 2. Square root of x squared, we can just cancel it out, huh? So we just get x, right? If we do that, then 2x minus 2x is just 0 though. Something's wrong. What is it? I don't know. Alright, here's the thing. When we have the square root of x squared, when we cancel the square root and also the x squared, it's not necessarily just x. In this case, the output of that is actually negative x. So I will have the negative right here for you guys. all right? And I'm going to explain why on the side, all right? So here's the deal. When we have, so let me put down a note right here. When we have square root of x squared, if we just cancel this and that and say this is x, this is not correct. For example, square root of -4 inside like this square, can we just cancel this and that and say the answer is equal to -4? No, because the output of a square root function has to be positive. So what we do is that when we cancel this and that, we attach an absolute value. So when we cancel this and that, we attach an absolute value, and the absolute value of -4 is equal to 4. All right? And of course, if the inside is positive already, when we cancel out, we don't have to do anything like this, right? And let me just convince you guys that this is actually correct, because square root of -4 squared, we will have to do this inside out. So -4 squared is 16, and then we take the square root, and you see the answer is equal to 4. Yeah? So that's why we need this absolute value. And when we have absolute value, you have to remember the piecewise definition. This right here is just simply equal to x. If x is greater than or equal to 0, you don't change anything. But if this right here is negative, meaning if x is less than 0, then we will have to negate the result. So we actually get -x, like so. Yeah, that's the math operation to make the negative positive, right? Negative times negative. And that's why square root of x squared here is -x, because x is approaching -infinity. So we are using this part here. All right. So all in all, what are we going to get? On the top, we have the 3x. On the bottom, we have this and that. -2x minus 2x, we get -4x. Cancel out the x. Ladies and gentlemen, the answer is -3/4. Right? Let me just write this down a little bit better for you guys. Yeah. All right, pretty good. So that's the answer. Be really careful with this. That's it.